let's pull back the curtain on something that happens every single time you go online. It turns out, for everything you do, the internet has to make a fundamental choice. Should this be fast or should it be perfect? This is the secret story of TCP versus UDP. I mean, just think about what's happening on your computer right now. You've probably got this explainer streaming, maybe a few other tabs open, music playing. It's a constant flood of data. So how on earth does your computer know which bits of data belong to your video call and which ones are for that file you're downloading? How does it keep it all from becoming one giant jumbled mess?
Well, the answer lives in a part of the network stack called the transport layer. And the best way to think about it is like the world's most efficient mailroom. Its job isn't just to get packages to the right building, it's to make sure every single piece of mail gets to the right person at the right desk without fail.
And this right here is the magic trick. See, getting data to your computer's IP address, that's only half the job. The transport layer does something called process-to-process delivery. It makes sure that a chunk of video data finds the YouTube process, and not, say, your online game. It's that last, critical step that takes the mail from the building's front door right to the specific person who needs it.
Now, this mailroom has two primary messengers it can use to deliver all these packages. And honestly, they could not be more different. One is super careful, meticulous, checks everything twice, and the other? The other is all about pure, blazing speed. And that brings us to the big idea for today. It's this fundamental trade-off. On one side, you've got TCP, which is like sending registered mail. You know, it's tracked, you get a confirmation, and you're guaranteed it'll arrive perfectly. And on the other side, you've got UDP. That's your postcard. You just scribble a note, drop it in the mailbox, and kind of hope it gets there. It's wicked fast, super simple, but there are absolutely no guarantees. So let's start with a speed demon of the two. Let's talk about UDP, the protocol that puts speed above everything else.
UDP stands for User Datagram Protocol. And the two words you really want to remember here are connectionless and independent. With UDP, every little packet of data is its own thing. It gets sent out into the world all by itself. There's no formal connection, no hello, how are you, and the packets don't know or care about each other. And this is the secret to its incredible speed. The entire UDP header, all the addressing information it needs, is just 8 bytes. That's it. I mean, that is ridiculously small. It's like the tiniest possible wrapper for the data inside. Because think about it, that tiny header means there's barely any work to do. It's minimal overhead. The system can just slap that 8-byte header on and boom, fire it off. This whole design is engineered for one thing and one thing only, to be as fast as humanly or, well, digitally possible. So you might be asking, why would I ever want to use the postcard method? Well, think about a live video stream, or when you're playing an online game, or on a voice call. In those moments, getting the next piece of information, the next frame of video, the next soundbite, is way more important than making sure you got the last one perfectly. A tiny, unnoticeable glitch is way better than the whole thing pausing to find a lost packet. Okay, so if UDP is our fast and loose messenger, what's the alternative? Well, now it's time to meet its polar opposite. The careful, by-the-book, and unbelievably reliable counterpart, TCP. The Transmission Control Protocol, or TCP, makes a massive promise. It says every single byte you send will get to where it's going. It will have 0 errors, and it will be put back together in the exact order you sent it. But to make a promise like that, you can't just throw packets into the void. You have to establish a proper connection first. And that connection gets started with something called the three-way handshake. Honestly, it's just like a polite little digital conversation. The client sends a SYN packet, which is basically like saying, hey, you there, can we talk? The server replies with a SYN ACK, which means, yep, I'm here and I'm ready. And finally, the client sends one last ACK to say, awesome, connection made. Only after that little chat is done can they actually start sending the real data. So how does TCP keep that big promise of reliability? Well, it's got this entire toolkit of features. It uses sequence numbers on every packet so it can put them back in the right order. It uses acknowledgements to confirm every piece was received. And it has all this smart logic for flow control, error control, and even congestion control to make sure it doesn't break the network. It's a full-blown traffic management system. But, and you knew there was a but coming, right? All of those amazing features come at a cost.
They need a much bigger, more complicated header than UDP's tiny 8 bytes. And all that extra info means more processing, which makes TCP slower. And that's the trade-off, plain and simple. You give up some raw speed, but in return, you get rock-solid dependability.
So we've got our speedy postcard and our reliable registered letter. But what's stopping somebody from reading our mail while it's in transit? And is this really the only choice we have? Speed or reliability, and nothing in between?
Well, for the security question, that's where transport layer security, you've probably heard of it as TLS, comes into play. The best way to picture it is like a cryptographic security blanket. You can wrap it around both TCP and UDP data to encrypt everything, making sure nobody can spy on your conversation or mess with your data. So if we go back to our mailroom analogy one last time, TLS is the armored car. It doesn't care if it's carrying a fancy piece of registered mail or a simple postcard. Its job is to make sure whatever's inside gets there securely, with no peeking along the way. But the evolution doesn't stop with security. For years, developers and engineers have been asking that second question. Do we really have to choose between UDP's speed and TCP's reliability? The answer to that is driving a whole new generation of protocols that try to give us the best of both. And one of the most exciting is SCTP, the Stream Control Transmission Protocol. It basically combines TCP's reliability with some of UDP's flexibility. It has this incredible feature called multi-streaming. So if your video stream gets stuck for a split second, your audio stream can just keep going without a problem. It can even use multiple network paths at once for even more reliability. It's a really cool glimpse into the future.
So every single time you load a web page, join a video call, or start up a game, deep down in the code, this invisible choice is being made for you. Speed or reliability. A postcard or registered mail. It's a constant balancing act. But now you know exactly what's going on inside the internet's secret mailroom, and you understand the fundamental trade-off that makes our whole digital world possible.